Welcome everyone to this week's virtual star party. If you have jumped right in, well, thank you, and we're glad that you're here. We're in the early beginning parts of the show where we are tweeting, we're pulling in telescopes, and everything is just getting started. Now, one of the things that we're finding is things are constantly changing over at Google+. So we've been getting asked a lot of basic questions, and I'm going to try and answer them. Folks are asking, do we know if you're in the audience? No, we don't. You need to +1 so that we know you're out there. Folks are asking if we have the lists of names. No, we also don't have that. So the only way we're ever going to know you're out there is if you +1, if you send us a comment. Folks often ask, how do you get in the star party with us? Well, you need to get a telescope. This is what's called a Google Hangout on Air. And the people that we invite to hang out with us inside this space that you guys get to see, these are all the wonderful people who have telescopes that are donating their time, and we'd love for you to join us. But we can only have 10 people in here at once, and we can share their content out to the world. So we're only letting in the folks that have the telescopes that are sharing the data. And right now they're one by one logging in from around the world. And if you want to join us in future weeks, go ahead and send us a note. I'm Pamela Gay. You can reach me through Google+. I'm Starstrider on Twitter. And like I said, we'd love to have more people joining us. So one by one, the telescopes are slowly coming in. Now, one of the things that we're struggling with is some of the things that we've relied on in the past, like embed codes and things, aren't where we expect them to be. So we're hoping to get this going over on CosmoQuest, but we're having problems with trying to figure out how to get the embed code for something that's live. Aha, I think I finally found it. You have to go to YouTube. So for those of you who, like me, have been trying to figure out how to get embed code for the new Google Hangouts, you have to follow the YouTube link, go to the live YouTube stream, grab the live YouTube information, and then hopefully that will work. We're about to find out. No, it doesn't work. Okay, this was an important lesson learned. The new embed codes do not work like the old embed codes. I apologize for the prattling. We're still waiting for a couple more telescopes to join us. So we have Peter Lake down you're in Australia this week?
That's right, yeah, I'm not at home today. I'm up at Siding Spring in Central West New South Wales in Coonabarabran, where the Australian National University have Australia's #1 observatory, and a lot of telescopes up here. I've been out and taken a few photos of them, so I'm happy to share them with the team today in between your live photos. So.
That would be great. Also with us, we have David Riley over in the United Kingdom bringing us a fabulous image of Saturn. Can you tell us anything about your system, David? I'm not sure David has a microphone. I'm so sorry. David, if you're talking,
can you hear me?
Hear you. Yes, now we can. You want to tell us about? It's all right. Do you want to tell us about your system?
So it's a 6-inch Newtonian, and I'm capturing the images with a Philips webcam.
So that's just an off-the-shelf, you can buy at your local store type of webcam.
Yeah.
That's a really neat image. So you see how simple it is out there, folks. And you have a tracking system on your Newtonian. Can you tell us a little bit more about this system?
That's a Skywatcher EQ6 mount.
So that's the type of thing that you can get at just about any good telescope store. One of the ones that I think is a favorite of many of us is Oceanside Photo and Telescope here in the United States. Do you have a favorite place for anyone else who's up way too early over in the UK, where they might be able to get a system like yours?
I got the mount from First Light Optics, and then I got the telescope from David Hines, which is a celestron dealer in the UK.
That's awesome. Now what's really cool about Saturn is if you've been watching it for the past several years, back in 2009 it went through its own version of equinox, and the rings were exactly edge-on. And so you just saw this straight line going across the disk of Saturn. And as we're approaching southern hemisphere summer, we can watch as the rings tilt. Sorry, they're tilting this way, so that we can see the leading edge crossing the top, the trailing edge across the back, and you can just start to make out in this image the shadow of the planet against the rings in the background. Now, we're right now going past Saturn's opposition, so that shadow is really tiny right now, but over time it will change, and just like Galileo saw it, it will appear to be two disembodied ears to either to one side of Saturn. So Gary, is that a live image, or you're still dealing with daylight, aren't you?
No, that's a live image.
Oh, that is a live image. Okay.
I'm cycling on 10 second, so it's continually refreshing a 10-second exposure.
Awesome.
So the Orion area is going to be out of range here in the next few weeks. It's very low on the horizon for me right now. Pretty much for everybody. You can see I'm pointing pretty low.
Yeah, we're going to lose that soon as we go into summer.
But that's why I wanted to hit Orion, Horsehead, and then there's a new one, Monkey Head, that I hadn't heard about. We'll see if we can see that.
I haven't heard of that one.
Yeah, it's in the upper Orion. So, but this is a 10-second exposure. Nope, that's not. And I can stop it and do a 60-second here, and we'll see all the little wispy stuff.
Now, why don't you go ahead and do that? And Peter, do you want to show us one of the images of the area that you're in?
Yeah, great. I'd love to. Let me just get the file up. So this is located about 400 or 500 kilometres northwest of Sydney, for those of you who know Australia. And it's an elevated area above a very flat western plain, and it's called the Warrumbungle Ranges. I'm just getting my stills up here. There we go. And it's famous national park, and you can see here we've got a number of the mountains. This one's called the Bread Knife and the Pyramid, and a number of different mountains there. And this is actually taken looking west from the ridge line that all the telescopes I'll show you are on. All the telescopes are on the ridge line, and we've got a number of them here you can see. And I'll give you a bit of a perspective here. This is where I am, and Pamela, just interrupt me if you want to go back to a live image, and we can come back to the backstory here. So yeah, so on the horizon line here, I'm not sure if you can see in the distance on the left, we've got the what was called Forks South, which is Las Cumbres Observatory now. We've got the Schmidt 1.2K as we go along the ridgeline. The big one on the right in the background is the 4.3 meter, the 3.9 meter AAO, the Anglo-Australian Observatory. As we come to the foreground here, we've got the Sky Mapper, we've got the two HAT Hungarian exoplanet research telescopes tied up to this little container shed here, and then we have Brian Schmidt's Sky Map. Actually, that one's not. That's the. I think this one on the left in the foreground is the Research School of Astronomy telescope of the Australian National University. The Australian National University run the whole mountain here. They kind of own the land. They work with the Indigenous community to make sure their needs are met. They work with the science community across Australia and the governments to make sure that you know, that the site is protected. One of the interesting things, all the telescopes on the mountain has to be built in such a way that can't be seen from the road up, except for the big obvious one, obviously, which is a bit hard to hide, as part of the respect for the local community, Indigenous community, the Aboriginal community in the area, and the fact that it's within a national park boundary.
It's a beautiful area, and we'll go back to you in a minute for some more, and I'm going to bring up the Aboriginal issue, because it is a problem in so many of the different places we build telescopes. But Gary, you seem to have your 60-second exposure out now?
Yeah, take myself off mute. Yeah, this is the 60-second, and I can stretch it in different ways to see different parts. If I bring it down like this, no, that's too much. That's way too much. You can start to see the real wispy stuff around the edges out in here. But the center gets blown out.
So I see Kenny Melgar, sorry, I'm going to mispronounce names, as I always do, is asking if this is illuminated by a star cluster. Well, what's really amazing is this is, the bulk of this is illuminated by just a very small number of extremely bright stars in the center of that cluster, the trapezium in particular. And these are all stars that are tens of times larger than our sun and are going to someday explode. So what we now see is this beautiful glowing cloud of gas that is dense in the center with tendrils of material out towards the edges if Gary changes the settings again. All of this is going to get blasted apart in the next 40 to 50 million years as those stars one by one go off as supernova. And since the system's only a few thousand light years away, when I say 40 to 50 million years, that includes flight travel time in the guesstimations. Someday where Orion currently has this beautiful glowing sword, he's eventually going to have, I guess, a bouquet of flowers from all of the supernova remnants there. Although due to galactic rotation and things getting spread out, the constellation will be thoroughly destroyed by then. But the stars that are currently making up the sword are all going to explode, which is just kind of fun to think about.
Yes. Here is a 1 second exposure, just to give you an idea of the illumination in the center.
And there
I'll stretch that out, and you
you
can start to make out the stars.
It's really kind of awesome.
So we got that one. I'll move on to another one and see what we got here.
And David's just sitting there calmly taking image after image with his webcam of Saturn. Now, David, is this something that you're able to combine these and later produce very sharp images?
Yeah, I can do.
Do you have any examples you might be able to show us?
Yeah, I took some yesterday that I posted on a Google Plus stream. Do you want me to try and bring an image up and share it on through
Yeah,
here?
if you could do that, that's easier than trying to,
Okay,
and a little less meta than trying to pull up Google Plus within a Google Hangout.
Yeah, I'll see if I can do that then.
So the technique that David's using is one of the best ways for getting crystal clear images through Earth's atmosphere. What he's doing is taking image after image after image, and in the video you see Saturn seeming to move around, but if you take any single frame of that video, you can align it with the other frame and take out that movement. And by stacking together all of these different moving images, but aligning them to take out the movement, you're able to get extremely high-resolution images. This is the same sort of technique that was used by Andrea Getz to image the center of our Milky Way. And sorry, I'm muting some of the echoes out here. She took a whole series of images of the center of our Milky Way this way, working in the infrared, and using infrared telescopes, she was able to see the individual stars moving around the central supermassive black hole. And you can't see that if you try and do one long-term image, because there's just too much movement, and the area is such a small area on the sky. But by doing what's called drizzle photometry, when you start doing it with big fancy multi-million-dollar telescopes, but the same process that we do with the video images, she was able to get these extraordinarily high resolution, and David uses the same technique to get extraordinarily high resolution through our atmosphere of nearby Saturn. So it looks like David's still working on pulling up an image. Now, Gary, you have an airplane going through your field.
Yes, I do. Right there.
That's rather spectacular.
So let me try another shot. That's a 60-second. I'm fairly near to Ontario Airport. It's about 4 miles south of me. So that does happen.
It does. So the way we're able to differentiate between an airplane going through the field of view and a satellite going through the field of view and an asteroid going through the field of view is airplanes are huge and bright and flash. So you end up with this pulsation period as they go through the image. Satellites, for the most part, over the length of an image that we take with the CCD, they're going to be fairly constant in brightness. And asteroids tend to be either look identical to satellites or fade radically as they go through the field. Now what's neat is you do also get satellites that do a dashed line as they go through because they're rotating. So that's one of the interesting things that you sometimes see.
Okay, here we're coming up on one that shouldn't have an airplane in it. And I just realized there's more noise in there than there should be because I didn't have the cooler turned on the camera. So once I try to subtract the dark, it makes it worse.
Oh.
But it's on now, so let me flip this so that everybody can see it the way it looks right. Flip, there we go. Okay. So there's the horse head and the flame nebula, and I don't know if you can see it on there, but there's a lot of little specks that are the noise. Normally I cool the CCD. I can go 40 degrees C below ambient temperature, and I'll take dark pictures with the shutter closed at that temperature, so I have the fixed noise that comes out of the CCD, and then I subtract that from the final image. And I'm doing that on the fly here, but since I didn't have the cooler on, I'm seeing a whole lot more noise. But it's coming down now. I'm at -4. I'm going from -15 C, and I'm down to -5 now.
Okay, so that'll cool off and get us better images quickly. So for those of you who don't understand what he's talking about, the reality is if you have a camera that's hot, when the light hits the camera's detector chip, it causes an electron to be created, and it's the electron that the detector worries about. But if it's hot, that electron bounces all over the place, and it sometimes bounces into a different part of the image where you don't want it. Now, the majority of the electrons created by light hitting the detector stay put, but it's those moving ones that create noise, and as you cool down your detector, the chance that the electrons are going to bounce around gets lower and lower and lower. And with professional systems, we use liquid nitrogen to get our systems down to -70 degrees, and liquid helium, which gets you even further down if we're trying to look at things in the infrared. So cooling is important. But it looks like David's managed to bring us up an image. So
Yeah, this is the one from last night.
that's nice. You can make out the Cassini division in the lines.
Ooh, excellent.
I've got one from the last opposition here as well, so you can see how the rings have changed.
Yeah.
That's from last year's opposition.
So this is just what you're seeing is over time, it's staying tilted the same way the entire time, but our perspective's changing. I'm looking to see if I can find a disc on my desk, and the best I have is this lid off of a thing of candy. So if the rings are always tilted the same amount, sometimes you see them like this. But over time, as the North Pole of the planet rotates towards us and then away from us, our perspective on the rings changes. So it's not that the rings themselves are tilting, it's that you have this constantly tilted system, and just over time, our perspective on where we see the tilt changes. It's the same reason that we get summer and winter here on the planet Earth, and in fact Saturn gets summer and winter the exact same way. Now what I'm loving is you can actually make out in that image one of the white storms up around the northern latitudes. So this is still the image from last year that you're showing?
That's right, yeah.
Yeah, so right after equinox last year, there was this amazing storm. Can you point to it with your mouse, David? See the white stripy bit? Yeah, so that storm up there was initially detected by amateur astronomers when it started to poof out in the atmosphere. And it's studied in great detail by the Cassini mission, which is out orbiting Saturn. And that storm is just one of those things that happens in the changing of the seasons on Saturn. And it's just neat to think of Saturn as having changing seasons. So I'm now going to switch over to Stuart, who I didn't realize that was Mars he was showing. This bright red object here is Mars. I thought that was like a laser beam and you were collimating or something. So I apologize for not clicking over to you sooner. Can you explain your image? You must have a filter of some sort on that. I may have muted you. You may need to unmute yourself. I'm sorry. So while he works on unmuting, I see some comments over in the side. I'm sorry for muting you with such vehemence. There should just be a button up in the upper right that you should see a microphone in the upper right of the Hangout window. Just click on it, and that should unmute you. So close out of the settings window, and then just go to the upper right of the Hangout window. And there should be the microphone, video camera, and settings icons. Just click the microphone icon. We were getting echo earlier, so I muted both Stuart and Gary, and I'm afraid I may have trapped Stuart in silence. Okay, so there's the Hangout window. So while he's working with that, I'll look at some of the questions in the comments.
Are you there?
Feed. Oh, yes. Cool. We have Stuart. Go ahead, Stuart.
Can you hear me now?
Yep.
Okay. All right. Sorry about that. No, I don't have a filter. What I'm using is a color imaging source webcam, and I have it at the equivalent of about a 2-meter telephoto lens. I have a 980 millimeter scope, and I have a 2x Barlow on it, and so it's whatever 980 times 2 is. That's what the length of the magnification is. If you look at this, you can. It's bouncing around a lot because of atmospheric interference, but you can see some surface features on it. You can't really see the polar ice cap. I wanted to try to get this first, and then I was going to try to pump it up to 4x view, but I wanted to make sure that you guys could see this first before I screwed everything up.
No, that looks fabulous. You can actually make out the darker sections on that surface. Those are totally real. One of the awesome things about Mars is it has different features that are different colors, and then it also has extraordinarily deep canyons. And we can see those from the planet Earth as just slight variations in coloration. Now, if you try and magnify it too much, you will start hallucinating that you're seeing canals and cities.
Exactly.
Those aren't actually there, so we discourage over-magnification. But nonetheless, it's an object where you can see actual features on the surface of another planet that's not exactly nearby. So I'm going to switch back over to David, who I have to say it's 4 a.m. where he is. It's going on 4:40 in the morning where he is. So this is just awesome that he's bringing us the view. And I see that in the questions, and Gary, can you mute yourself? You're echoing. I see in the comments the question of why is there a bluish halo around Saturn, and you actually see along the bottom of Saturn it's kind of blue, and along the top of Saturn it's kind of red. And this is what's called chromatic aberration. Anytime you have...
It's a bit misty here as well. I think that's part of the...
Okay, so it's atmospheric aberration in this case. So do you have any lenses in your system, or is this straight mirrors and that's purely the atmosphere doing you in?
Well, I've got a Barlow lens in there, well, a power
Okay.
mate.
Okay. So what happens is when light passes through different substances, it can get bent. That's called refraction. When light passes through moisture and you get rainbows, that's because the different colors bend different amounts. So a water drop and a lens are, as far as light is concerned, the exact same thing. Both of them cause light to bend, and both of them cause light to bend in different amounts for different colors. Red doesn't bend quite as much as blue does. And so in this particular image, what you're seeing is the red and blue light just doesn't focus in quite the same place. So you end up with red along one side and blue along the other. And if you're able to separate out all the colors of Saturn, you'd see that there's actually this little tiny rainbow of Saturn going across the monitor. And it's where all those colors overlap with one another that you see the colored Saturn that we all know and love so much. And this is just one of the unfortunate problems with using lenses. And you get much better contrast with lenses, but people tend to turn to using telescopes with mirrors to get away from this chromatic aberration, this color bending problem. Mirrors, it's just it's a reflection, so you don't have that difference for different colors. But you don't get the same high contrast that you get when you're using a lens system. But you can build mirrors much bigger, because the problem with a lens is you can't exactly put supports behind it because you have to look through it. With a mirror, you can build a 20-meter mirror and just put supports all the way across the back of it. And so you can get much, much bigger telescopes, and that compensates for all the issues that you might like in a lens. So it's complicated figuring out how you want to build your telescope and what you're going to build it for. So now that I think we have everyone in the Hangout, I'm going to step back and do basically a channel announcement. My name is Pamela Gay. I'm on the faculty at Southern Illinois University, Edwardsville. I'm in the process of standing in for the normal host of this virtual star party, which is Fraser Kane, the producer of Universe Today. Fraser is currently off enjoying a much-deserved vacation with his family in Europe, and he will finally be back next week, and there will be much rejoicing because he's awesome at doing this and the organizer of all of this. With me tonight, we have showing Saturn, David Riley with his Newtonian telescope over in the United Kingdom. Next to him, showing the Horsehead Nebula, is Gary Ganella, who's over in the Los Angeles area. There's Gary. We also have showing an image of a dome off in Australia. We have Peter Lake coming to us from down under. And coming to us, are you in Arizona right now, Stuart?
No, I'm in the San Francisco Bay Area.
Okay, so coming to us from the San Francisco Bay Area, but sometimes coming to us from Arizona, I think, or I'm confusing him with Ray Saunders.
That's Ray Saunders.
Okay,
yeah,
I'm confusing you. Sorry, you
yeah.
temporarily became one location. Coming to us from the San Francisco Bay Area is Stuart Foreman bringing us Mars, and this is CosmoQuest's virtual hangout. If you would like to keep track of when we're going to be doing these things, please follow us on Google Plus and Twitter, and we'd love to see you over on our website, cosmoquest.org. We will be, once we get everything uploaded and edited, posting all of this on YouTube on the Astrosphere Vids channel. So it's a night when a lot of us have been fighting weather, but we were able to get some fantastic views in. Now, Gary, how's the cooling down on your system coming?
There we go. I'm down. I'm down at minus 15, and it made a huge difference. I don't know, you know, once we're compressing the picture and sending it, you may not be able to see it, but I saw a lot of little single pixel speckles in here that I'm not seeing now. So that's a 1 minute exposure, and the Horsehead Nebula, the Flame Nebula, and looks like we had a satellite going through.
You're just in a busy part of the sky today.
I am. So that, just for whoever wants to know, that is Anatak, right? The left-hand star in the northern hemisphere. When you look up at the Orion Nebula, that's a left-hand star in the belt.
So this is a star that you can actually just go out, and if it's still early in the evening where you are, you can just go out and take a good look at this. So
Okay.
Peter, do you want to tell us a little bit more about your mountains? And Gary, you want to bring us a new object on the sky?
I'm going.
Awesome.
Okay, thanks, Pamela. This is in vertical format, so it's a little bit blurry. This is the 2.3 meter Research School of Astronomy telescope for the Australian National University. And I was there about an hour ago. I had to really hurry back and watch the clock because I had to drag myself away. They were lifting the 2.3 meter mirror out of the scope on a crane and lowering it into the mirror box to take it away to be recoded. And so that's why I was a little bit late, so apologies for that. But it's a great scope and run by the School of Astronomy at ANU. And Donna Burton there, who's one of the astronomers up on the hill here for the ANU, and she was there, and it was great to meet her. Moving around the hill, I realised when I put the photo up before that it mirror reversed it in the window, so I was actually giving directions the wrong way, but which apologies for that. And the Nobel Prize for the inflation, the supernova research. This is Brian's telescope, the Sky Mapper, up on Siding Springs, and that's one of the new telescopes that's going to do some of the sky mapping of transient events and asteroids and the like in the southern hemisphere. It's going to be a great research project, and I think my wife would be horrified to realise that she's on national television now, but on the national internet, I should say.
Yeah, international
the Sky
internet.
Mapper. Yeah. And just coming back to this photo, I was left to right, and I did it in the wrong order. I think the big dome there you can see in the distance, I think it's on the left in your photo, is the 4 meter, the 3.9 meter Anglo-Australian telescope, and on the left is the little oyster shell observatory and the two Hungarian HAT P exoplanet researchers there. So that's what I was on before. And of course, for those who've just joined us, the lovely view from the back of the mountain here, looking over the Warrumbungle National Park.
Yeah, it's really amazing all the different places in the world where they put telescopes. And one of the awesome things that's currently going on is the UNESCO United Nations. I have to admit I can never remember the rest of the letters, but it's the organization that determines what places on our planet we as a global community are going to work to protect. So there's various waterfalls, there's the Great Pyramids, there's dinosaur footprints, there's both natural and man-made places that are protected under UN sanctions. These are places that you're supposed to try and not bomb in case of war, and nations are asked to please put into effect things to protect those sites. And one of the new categories of things that is getting protected are dark sky heritage sites. These are the darkest places in the world where you can still go and you can still see galaxies with the naked eye. You can actually see 2 or 3 of them depending on how good your vision is. It's not just Andromeda out there, but you have to go someplace truly dark to be able to see that. And what's kind of awesome is the places that get protected as dark sky sites are places beautiful like this one, where you're getting to enjoy all the natural wonder that's also protected because, well, in order to keep someplace dark, you don't want human beings, so you end up with squirrels and deer and bear and all sorts of other critters running around. Skunks, unfortunately, they sometimes join you while observing because they're nocturnal.
Kangaroos here.
Yeah, kangaroos. I know one astronomer who actually got beat up in the middle of the night when she stepped on a kangaroo. So all of these wonderful things are out there being protected while we protect places for science. It's a great synergy, science and environmental protection all tied up into one. Now, Gary, you've gone to something absolutely amazing looking that I don't think I've ever seen before. What are you pointing at?
This is the monkey head. It's in Orion. If you take Betelgeuse as Orion's shoulder, that arm up near the very top of the arm it is. It's also an NGC 1275 designation. And I have never seen this one before.
That is very cool. Now, one of the awesome things about Gary's telescope is he's looking at the entire sky through an H-alpha filter. So everything he looks at, we know ahead of time is red if it's bright in his system. And so this is going to be one of those nebula that's out there that's rich in hydrogen gas that has been heated up by something so that you end up having, it's called the 3-to-2 transition in the hydrogen atom. If you've watched other star parties, you've heard me talk about this before. It's where an electron gets excited or recaptured such that it ends up in the third energy level of a hydrogen atom. And as it jumps to the second energy level, it gives off a bright red photon that's the exact same color as an open sign at your local deli or restaurant. So this is a region that it's an emission nebula. So there's an open cluster of stars that's heating this up, young stars giving off a lot of light. And this actually bridges nicely the light coming from the stars to a suggestion that showed up on Twitter where we have Icarus Factor asking if someone could test out some laser cooling telescope cameras. And this, I have to say, would be a very bad idea because of all the photons involved. When you're cooling down optical systems, you want to minimize the number of photons that are harmed in the process. So there's lots and lots of different ways to cool off systems. We really, unfortunately, do need to stick to either full photoelectric coolers or, more efficiently, to just drowning the sucker in liquid gases, which sounds odd, but I think everyone knows what I mean.
Pamela, would you like me to try to get Mizar for a double star?
That would be awesome. And we also have a request for Solaris.
Okay.
Now, David, you seem to have gone black. Are things all setting over where you are, or are you getting clouded out?
I'm losing Saturn to the cloud now. I was just thinking I could try and get Albirio in the...
Oh, that would be fabulous. Your system's great for that.
Yeah.
So
I'll
one
give
of...
that a try.
Excellent.
The sun's just starting to come up as well, so it's starting to get light over that side, but I'll give it a try.
I love the issues we're dealing with. Gary over in Los Angeles area, we were struggling, waiting for the sun to go down for him, and now poor David, we're losing Saturn as the sun begins to rise, and then of course Peter, it's just daylight over in Australia, and you can't really see anything out my window other than the fact that through my window is black. So yeah, here it's deep at night and it's pouring rain outside. So I'm glad I'm not one of the ones with a telescope. So Gary, can you play with the stretch any on this so that we can see any of the details?
Yeah, a little bit. I was rotating it to see if I could figure out why they call it the monkey head.
Have you ever seen a little tamarin monkey? To me, it looks a lot like a little tamarin monkey.
Like the head here and eyes. Yeah, that's why I rotated it.
So I actually kind of see in the upper right, you can sort of see right where your mouse is. Yeah, right there is a mouth, and then above to the left is an eye.
Ah,
and
yes.
And then you can see the edge of the hair going down, some above the, and there's the hair. Yeah. So I look at that and I see a happy little tamarin monkey threatening to steal my lunch, because that's what tamarin monkeys do. They steal your food. But they're cute when they steal your food, so it's okay.
Yeah, if I stretch it, I can stretch it a little bit more, but then I start blowing out the center. And if I bring the lower down a little bit, it washes out the picture, but you start to see more of the misty stuff around the outsides. It's always a trade-off where you want to set the picture.
Yeah, and this is, we were talking about this last week, this is where to get some of the spectacular images you see in calendars and such, people are doing HDR, high dynamic range photography, where they're doing multiple images at different depths so that they can bring out all the different features when they combine their images together. Now looking over in the comments, I love the comment made by Christina Ward. This is so amazing to watch, a star party without freezing. Yes, this is why we love technology. There's still a whole lot of freezing to death doing astronomy. I'm sure that David is quite chilled where he is. Gary and Stuart off in California are probably quite fine. But there's still a lot of getting cold setting up. But nowadays we can, Peter, when he's observing during broad daylight in Australia using telescopes in New Mexico and Arizona here in the United States through a robotics system. So technology is allowing us to do new and more interesting things. There's questions about where are some of the other usual suspects. Okay, sorry, what were you saying, Peter?
I was just going to say I've got a little surprise for you later,
Okay.
Pamela. With I've got Robert McNaught's first telescope outside. I'm going to show it to you live. So when you're ready, we'll go and have a look at that.
That sounds great. So we're about to get a double star, and then after that we can wander outside with Peter while Stuart's working on bringing in either, I don't know if he's getting Polaris or the double star right now. I'll answer some more questions. So Chris Ridgway is asking where some of the usual suspects are, and there's a lot of people having a lot of really bad weather. If you look at a map of the United States, we have a couple bands of extraordinarily bad storms with tornadoes and high winds associated with them. So there's a lot of people that are simply hunkered down, hoping for the best, or at least hunkered down, deciding it's really not the night to go outside and try and do anything unless you want to try and fly a kite, which you don't usually do in the dark. So I also see Mitchell Duke was asking about why Mars is just a little too red, and that's just the nature of the camera that's being used. Now, are you resolving everything, or are you somehow duplicating the system, Stuart? That's a very confused image.
Oh no! I'm using a I call it a Baryshnikov mask, but that's not what it is. I'm using a diffraction grating to focus right now.
Oh, thank you. That makes a world of sense. I couldn't figure out what on earth you had done.
Yeah.
Okay, there we go. 2 stars. That makes more sense.
Actually, you see 3. So you see the 2 stars there, and then the one off to the upper left.
Yes.
You see Alcor and Mizar. So Mizar is the bright one with the double star, and then Alcor is the dimmer one off to the upper left.
So this is the set of doubles that you can see in the Big Dipper. I'm in the right system, yes?
Yes.
Okay, it's 11 p.m. here. I have to
No problem.
check my knowledge occasionally. Yeah, so what's kind of awesome is it used to be, I believe it was the Roman military, you had to be able to divide these stars with your eyes in order to be allowed to be in the special services. So binary stars were once a vision test.
So I love double stars. I think they're just kind of cool.
Yeah, and this is the one that if you had even a higher resolution system, you could break it down into 4 stars, couldn't you?
No, I think that's Vega, the double in Vega.
Vega's
that
a
you're
star.
thinking. No. Yeah, that's it, isn't it?
Okay, this is where Googling is going to be required.
Yeah, okay. It's not summer yet. I'm still on winter mode.
This is one of the things that you run into is we all lose stars late at night. One of the problems with observing is you have to do it at night. So while we solve this problem, I'm going to switch over to you, Peter, and you can explain the telescope that you're showing us, which is a
Well, can you hear me okay? Yeah.
Yeah, go ahead.
So everyone starts somewhere. And we all probably have our stories about our first telescope. And this is Robert McNaught, the famous comet hunter and asteroid hunter, who's been up on the mountain here for many years with the Uppsala telescope. I think it's E16 off the top of my head. And Robert is a legend, and you all remember the famous comet McNaught that graced our skies a few years ago. This is Robert's first telescope. It's a Dobsonian mount, and it's made out of a steel downpipe that's been reinforced with fiberglass around the focus area, and a traditional kind of boxed Dobsonian mount. And John Dobson would be very proud of this telescope because, well, we don't want to be too unkind here, but it does look like it's made of junk. And John Dobson is famous for his quote that Dobsonian telescopes should be able to be made out of junk. And this one's kind of outside here. And but Rob's, got it. He's over the back here, and he's allowed us to have a look at it. So it's his first telescope, and everyone starts somewhere. And no matter who you are, where you are in the world, you can engage with science and start with an interesting telescope that you built yourself, or one that you buy, and you can begin your science journey from there and move on to the many great systems around the world and pursue a career in science yourself.
It's really amazing if you have a kid and they have any interest in astronomy. I strongly advise, as a science fair project or something like that, build a telescope. You can get the pieces for a reasonable amount of money. Don't grind a mirror your first time out. Just build something simple, PVC pipe, and you can actually use cosmetic mirrors if you're desperate.
Yeah. I don't know if you can see here, this is actually a golf ball. It's that's very good. So anyway, I just thought wonderful. You might love to see that today. So
yeah. I love the way it's just sort of stashed in the corner with weeds growing around it. That's really quite fabulous.
It probably should be in a museum, I would think, because it's quite significant. It's the start of someone's great journey.
Yeah.
I don't know who wanted to see Polaris, but here it is.
That was a request from Aviva down in Indonesia.
And David, I want to say thank you for sharing that.
Yeah.
Does that look okay through the Hangout?
That does. So, oh, it just went away.
Yeah,
there it is.
Put the wrong window to the front.
So you want to tell the story of these two objects?
Well, one should look kind of orangey red, and the other should look blue. I don't know whether it comes across in there.
The blue comes across very well, and I love the sound of the birds waking up in the background where you are.
Normally, when I look at this visually, the orangey red looks quite convincing, and the blue doesn't look so convincing. It tends to look more white. Sometimes it's a lot easier to see the colours when it's out of focus, though.
You want to tell everyone which these two stars are?
It's Alberio, which is Beta Cygnus, I think. Is that right?
Yeah.
Yeah, it's in Cygnus.
So this is one of those great systems for. You'll often hear people say all stars are white. This blanket statement: stars are white. And the truth is, if you walk up to your average Joe and you say, "What color are stars?" they say white. But the reality is stars come in every color, although your eye will never perceive them as green. Go read this article over on Bad Astronomy about that. But stars come in every color, you just never perceive the green ones. And this is a system that when you look at through a telescope, you see orangey red and blue. And depending on what photoelectric detector you use, in this case you see white and blue, but it's such a clear blue. And then switching over to Stuart, Polaris, because of the nature of his system, is coming across as red, and it looks like it has a flare due to an interesting issue with your optics. That's kind of fun.
Yeah, it's probably just bad. I'm not quite focused exactly right.
Yeah. Now looking back at Alberio, trying to click back over to Alberio. My system's frozen. Come on, wake up. There we go. So looking back at Alberio, like we were saying earlier, this is one example of double stars, and when we were looking at Stuart's system, we were actually looking at 6 stars. So there are many different doubles and doubles out there, but Alcor and Mizar are kind of neat because Alcor is a binary star, and then Mizar, which you see as 2 stars, each of those 2 stars is actually another 2 stars. So one of the crazier sayings that we have have in astronomy is 3 out of every 2 stars is a binary. Parse that how you will. The reality is about 75% of the things you see in the sky that you perceive as just 1 star averages out to actually being 2 stars. So there's lots of triple systems out there. There's some quadruple systems out there. Those tend to be gravitationally unstable. But stars form in all sorts of different crazy ways, and then there's also chance alignments. This is one of those chance alignments that we're looking at right now. And those birds are kind of awesome. Do you have anything else bright left in your sunrise skies, or should we let you go to bed pretty soon?
I've got quite a lot of cloud as well, so I can't really see anything else at the moment.
Okay. So I have to thank you for bringing us such a fabulous view of Saturn, because no one else could have done it so early in the evening here, and that was truly wonderful. And the images you showed us from this year and last year's
Thanks.
oppositions were really beautiful. Everyone, I'd encourage you to go check out David Riley on Google Plus and look at the images that he's been sharing there, because he has some really nice ones that are cropping up in his Google Plus feed. Now, Gary, what have you switched over to?
Let me unmute.
Oh, sorry,
that is the, no, I did it. That's the Rosette Nebula. And that's another one that we're going to be losing for the season as it drops off the western sky and goes away for summer months.
Yeah. It's kind of frustrating.
Yeah, well, got this Earth in the way and have this sun thing that's causing problems. I don't know about all that. But this one is gorgeous with all the little tendrils, all the pieces that you can look at in there. And this is the one that always puts Fraser in awe.
This is his favorite object. And what's neat about this one is you have that open cluster of stars off-center up and to the right, and then you have all the nebulosity around it, and this is a system that's tens of light years across. Actually, it's hundreds of light years across and tens of solar masses. I reversed those 2 numbers, sorry. So this is very, very, very thin gas. If you were standing in it, you wouldn't really notice it, just like you don't always notice misty days until you look off in the distance and notice that distant towers aren't as crisp as you'd expect them to appear. But because we're so far away, we're able to look through the immense depth of gas and make out all of these beautiful tendrils where the gas is much denser and blocking out light, and then we see everything getting illuminated by that H-alpha line again, caused by the excited hydrogen gas.
Okay.
So do we have a few more final objects before we begin to pack it in for the evening?
Yeah, let me come up with a couple here. We'll see what looks like Stuart's on something.
Yeah, I'm just trying to get Mars back here. When I went to Polaris,
it's very round.
When I went to Polaris, I had to mess up my tracking.
Okay. So one of the problems that you run into with telescopes is they don't quite know how to handle being pointed at the North Pole, and one of the problems you run into with telescope domes is they don't quite know how to deal with the telescope being pointed straight overhead. And in both systems, the computers freak out a little bit because they're trying to deal with a lot of different things. What's interesting is if you're ever using a big professional telescope, as when you point the telescope straight up, normally as you watch through the night, the telescope will rotate through the sky, tracking the objects that you're viewing. And sometimes the objects that you're viewing, they'll track so that they go straight overhead. And as the telescope moves, the dome will rotate slowly to make sure that the telescope always stays centered in the big open slit on the telescope. Now, when the telescope's pointed straight up, the dome doesn't quite know how to optimize for that. And I know at least for a while, the 107-inch telescope at McNaught Observatory, when you were pointed straight overhead, it would just rotate, and the whole building vibrates, except for the telescope, because they build these systems where they'll have 4, 5, 6-story buildings with the telescope on a pier that is completely separate from the entire rest of the building. So you can do anything you want to the rest of the building and it will never affect the telescope. So we'd be sitting in the control room vibrating as the dome went round and round and round, and all of our images were crisp and clear. And you can actually see in Peter's image, off in the distance, one of these telescope slits that we're referring to, and that entire top of the building rotates as the telescope tracks through the sky. Now, on the right on this image, you see a completely different type of dome, and this is one that just opens all the way up, the clamshell type of dome. And those can be very nice insofar as you never have to worry about thermal problems. With a lot of domes, you have to worry about it's warmer in the dome than it is out of the dome, and as the light goes from cold air to warm air, it bends, and this just causes no end of difficulty. Well, if you open everything up, all the air gets let out. Everything's the same temperature. It works really well. Now, the only problem is on high wind nights, with a normal dome, you just open it the bare minimum that you're allowed, that you have to allow the telescope to look out. Sometimes you can open it this direction instead, and so you only open it part way up so that the telescope is just looking out this narrow window, and that way you protect the telescope from the wind and you can observe in bad weather, or at least windy weather. With a clamshell, you can't do that. You just have to stay closed in the wind. Now, Gary, is this Thor's helmet again?
Yes, it is.
This is one of my favorite objects. It's just cute and silly.
I love it, too. Let me see if I can get it centered a little better and zoomed in a bit. Yeah, that's Thor's helmet. And I'm going to need to cut things short here, Pamela. We've got my wife's folks with us, and there's a problem with her mother that I'm going to need to work with.
Oh, no. Okay. Well, we will wish you well, and it looks like this is probably a good time to wrap it up for the evening for everyone. We will see M13 later in the season. This is the wrong time of year for M13, people who are asking in the Hangout. And I appreciate everyone who joined us this evening. We will be doing the same thing next Sunday, weather willing. And so to thank everyone in the Hangout, we have David with us from the Sunrise in the United Kingdom.
And
Gary,
I'm going to say goodbye and check out here. Thanks.
Okay. Bye, Gary.
Goodbye, Gary. We have
Bye, Gary.
Los Angeles Basin, Peter coming to us from down under in Australia, and Stuart, who's a big black box at the moment, coming to us from the San Francisco Bay Area. And I love the sound of birds, and with that sunrise sound of birds, I think it's the right time to turn down the Hangout. So thank you all for being here, and the next Google Hangout will probably be Wednesday evening's Science Hour here in the United States, early in the morning in Southeast Asia. That will be starting at 4 p.m. Pacific, 7 p.m. Eastern, and I hope I'll see all of you there. So thank you, everyone.
Bye, Pamela.
Thank you.
Bye-bye.